Okay, wonderful. So welcome to ByteCube, and welcome to DataVis DC. My name is Carla, and I'm organizing this meetup for you this month. And we have our friends who were from Russia and New York coming all the way to DC to give us an intro on spatial temporal visualization. Just a brief roundup on who our speakers are. We have Nikita, we have Vadim, where is it? Oh, there you are, okay. And William. They are from a company called Habidatum, and they're going to explain more about their company later. And co-leading this month, I'm Carla. I work at the IMF, and I love to visualize macroeconomic data. This is Ruchita. She's a data analyst for Amida Technology, and she does a lot of geospatial work too. These are some of, okay, kind of messed up a little bit, but these are some of our organizers. You'll meet some of them in the coming months. Yeah, just a brief overview. So we're part of Data Community DC. We have a lot of other sister meetup groups. We have Data Science, Data Ed, Nova, Statistical Programming. We have to say thank you to our partners. They're in charge of giving you pizza and drinks for tonight. Partner companies, organizational sponsors, they're all in here. So right now we're recording this session, and they will be available on YouTube, maybe a day or two after. And then we also have a recap of all the events that we've had in the past. Okay, so now we'll have a few words from our venue sponsor. We have Evan from ByteCube. He's going to tell you more about this venue.
Thanks. I'll keep it short and sweet. My name is Evan Francis. I'm a senior technical recruiter over here. If you have not heard of ByteCube before, we're kind of this interesting intersection between a government contractor and a tech company. So we do try to host these meetup meetings pretty often, usually at least once or twice a month. A bunch of UX, UI, and data visualization. So thanks for coming out. We really have nothing else to do at this space after hours, so this kind of works out pretty nicely. We hope to see you all at more events. And if you have any questions about the company, what we do, or just like to chat with me, I'm going to leave my business card up at the front desk for you. So I'll hand it back up.
Thank you. Yeah, Ruchita's going to invite you to our next few meetups.
So we're going to have another meetup in March on the 27th. It's going to be about NASA Knowledge Graph. The speaker is going to be David Mizza, and he is the Chief Knowledge Architect with NASA. The co-presenting meetup groups are going to be Data Science DC, Baltimore GraphDB, and Columbia GraphDB. The next meetup is going to be in April on the 10th. Data Visualization 101 Best Practices by Trevor Filipiak. He's an analytics and business intelligence consultant with Diverse Solutions. So I hope you guys have fun today, and I hope you guys come to our next meetups as well.
So any announcements? Does anyone have any job openings or hackathons coming up, or any other meetups that they want to announce to the group? Job openings, anything? Yes.
Hi, I'm Aaron, and next week, on this very day, Tuesday, is Hack and Tell. dc.hackandtell.org. It's 5-minute lightning talks about personal projects that are fun. There. Hi.
Anything more? Job openings? No? Okay.
Hi, a friend of mine is looking for some side work, some help mapping telecommunications infrastructure in the Caribbean. It will be like, I don't know, like $5,000. So let me know if you're interested.
Nothing? Any more? Okay. And then our last announcement, data drinks will be at Highline. It's just across ByteCube. So after all of this workshop, then we can go and have drinks. All right. Nikita.
Thanks. Thanks for hosting us. Hi everyone, I'm Nikita, I'm a data scientist at Habidatum. And tonight we're glad to share with you the talk about spatial temporal visualization, which is, as I guess you can guess, visualization of data in space and in time simultaneously. So this concept can be applied to multiple areas, and the scope our company is most focused on and most interested in is cities. And I guess if you've seen any net visualization about cities, you usually see them in two different forms. The main one is a map. I guess most of you are familiar with maps, but just to give a quick round of hands, who here came because he is close to spatial analysis, to GIS, or something about cities? Who's from that camp? Can you show hands? Okay, and who's here because he is more about temporal analysis, some time distribution, charts? Who's from that camp? Okay, so more from that one, and lots of just curious minds, which is great. So, yeah, usually when we talk about cities and data in cities, we see maps like this. We have some layer of the addresses underneath, and we have some visualization on top, and it's nice, and it lets us understand how space works and how different data is distributed across the city. But one issue with that is that it's pretty static. And we as that visualization guys might think that it might not be static in the sense that it can be interactive. You can interact with it on a website, you can rotate it around, but the thing is it's static in time. We have a snapshot of the city at, say, some year. We see here the distribution of rats complaints in New York. So you know, okay, lots of in the downtown, some in uptown, but you don't know which were the causes of this distribution. And another approach is, if you want to incorporate time, we usually make some charts like this. So we make, say, an average number of complaints per the whole city, and we show how it changed across the day here, from midnight till midnight, or we show how it changed across a year or 10 years. But we usually talk about one or two charts. And this is usually pretty hard to incorporate. So if you want to see how the distribution of rats complaints change across different years, you usually just have multiple maps side by side, you look at them, you compare them, and this is how you usually work with maps and time. But this becomes pretty hard for multiple reasons. I would say two. One reason, because we need a new approach, is because our lifestyles are changing. Due to different reasons. Some of them are technological, we ride Uber, we're not so static, we change our locations, we go to different neighborhoods, and we are not that easily displayed as a population by some static maps showing, okay, here are where the people live and here are where they work in this year. This approach is not more that reliable. It doesn't let us make some immediate decision about what's going on, because our mobility patterns are really complex. And that's a challenge. But we also have some help in the sense of technology, which is we've got lots of data streams, which are much more detailed, both in space. Now we have GPS, and we can show us exact location with some 10 meters, if it helps with Wi-Fi. And we have high temporal frequency. We send tweets every hour, or Instagram every hour. We take an Uber with some really high frequency, and we pay with credit card, and all this data is collected by some companies, and we hope that it is private. And the cool thing is, while we want to be private, we would also like to have some insightful knowledge from this data in some aggregated way, which would help us understand the city without understanding each individual person, which is our goal. So yeah, we have complex movement, and we have lots of dynamic data. And to try to solve this issue, to make the analysis more dynamic and visualization more dynamic, we thought of the following system. This is the Chronotope. Chronotope is a word from two words, like chrono is time, and tope is topology, which is space. So the idea is to combine space and time into a single object, which you can now reason about, you can visualize it, and you can, what's very important, look at different layers of data at the same time, at the same canvas. So this is pretty messy and hard to understand, and it's okay to write it and see some like vessel something, some blood flowing through it. But the idea is that we can have multiple data sets. For example, it's mobility data gathered from salary data providers. It's sentiment data gathered from social media. And it's spend data in green gathered from, I don't know, Square or some payment provider. And we can, from these different layers of data, if we get a space where we can reason about it all together and see how it changes through time, which is very important here. So here we see x and y, this is space, and the time as a third dimension. It goes up. This is the time. We can think about new ways of understanding what's going in the thesis by combining these different data. And that's how it all works. But let's start slow, and let's start from an example we did in a project about Barcelona. So Barcelona is a very nice city. Someone can argue about it, but in terms of visiting and tourism, it's pretty attractive. And that's why the city has lots of tourists. And it's thought of that there might be some troubles or issues connected with that. There might be some places where there are too many tourists and locals at the same time. And they might not enjoy each other for different reasons. And on this map, what we see, this is Barcelona, this is city center. We see 3 layers of data. One is locals. This is data based on Twitter. The locals are red, they are quite widespread. There are also visitors or tourists, which are green, and the blue color is the places where they're both tourists and locals. So you might wonder, how do we get the locals and tourist data? Well, social media contains lots of different insights from a single tweet. For example, you can, of course, get the text itself and the location if it's there. But you can also get much more. And of course, for us, it's important to get the time of when this post was posted. But you can also get different things. For example, you can extract topics of discussions. You can see what people are talking about and understand their patterns based on their topics of discussion. So different people usually talk about different topics. You can also see the sentiment of a post, if it's happy or not, using deep learning or some more simplistic methods. You can still see if a post is negative or positive. And of course, what is more important, that sometimes you don't have the exact location, but you have the mention of some location in your text. So you can extract toponyms, and you can make understanding of which location this is talking about, or maybe which location this post was taken from. So we used Twitter data, and we used it to gather the data for a few months in Barcelona, and split all the posts and all the users to 2 types of people, tourists and locals. And we did it based on how frequent they have been to Barcelona, comparing to other countries. And if somebody is Barcelona for most of his tweets in the last year, well, most likely he's a local. But if he has been to many other places, there is high probability that he is a tourist. So that's the idea of how we extracted that. And we wanted to look at where are the locations where there are both tourists and locals. Because if they are there at the same time, they might be congested, and it's visualized here. So these are the squares of around 500 by 500 meters, where you can see intersection of tourists and locals. So well, we might think, okay, there are most of it in the center, but there are also lots of places outside the city. So you might think that this is pretty dangerous, but what might be important that maybe while they share the same space, which is they both go to this subway station, maybe locals go there at morning and tourists go there at noon. So they actually never meet in a 3-dimensional space and time space. Sorry for, yeah. So to analyze that, we introduced the 3rd dimension, which is time. So now all the squares in which you look at like a regular map, they represent not squares but huge like cubes going down, and the time also goes down. So in the bottom there, it's morning and it goes up, which might not make that much sense right now, but I hope it will let you understand on the next slide. So the idea is to add time as a third dimension. So we see the following way. This is a spatial temporal cube. We can think about it as a matrix, a three-dimensional matrix, or as a three-dimensional matrix. So we have latitude on this axis, and we have longitude on this axis. And on the z-axis, we have time. So what does it mean? This means the following. Like this is one cube, the minimal value of the cube. It's called voxel. It's similar to pixel, but voxel is like volume pixel. And there is such a word, people use it. Yeah, it's nice. And voxel represents a specific location at a specific time. So for example, if this is, I don't know, New York, this is Brooklyn maybe, some intersection at Brooklyn at 6 p.m. And this is the same Brooklyn at 5 p.m. And this is not the same Brooklyn, but some more western Brooklyn at 5 p.m. So you get the idea. And what's important that we can always count on this three-dimension to our regular projections, which is we can select one place and look at it as a timeline, or we can select one time slice. We call it a time slice, and we can look at this at just one regular map. So we combine that, and we come up with this beautiful thing, which is our Barcelona game, but now we're looking at it from the, I would say, from the side. So here is our timeline. It goes from midnight till midnight of the same day. So this is an average day. So we see here is the map, and here is the timeline, both on the same canvas, which is nice. So we can try to reason about it. So we see that this is midnight, and with these little voxels, like these are the voxels. You can see them all around the place and time. You can see that in the midnight there are not that many locations which have some intersection of locals and tourists. They got even less, and we come deeper into the night. But when the morning comes, we get more intersections. They spread around, and yeah, we see that. The other thing that's also easy to see here is that in the center is pretty constant, but we have some locations we have bursts of activity of both locals and tourists. And this is something that might be hard to see from above. Because if you see from above, maybe this value is really, really high. And if you just sum up all these values, it would be the same as here. And if you look just at the static map, you see, okay, here we have 100 people, and here we also have like 100. Pretty similar locations if you just look at space, but if you look at space-time, they're totally different. This is just a burst. Maybe there was an event with which both locals and tourists visited, and here is just a constant downtown center, which is always bursting with locals and tourists. Yeah, and actually the issue is not that high of a deal. If we now filter not show all the values where we have intersection, but only the places and times when the intersection is pretty high, where we have a lot of locals and a lot of tourists. This space and times go down a little, and we have a really, really little area in the downtown, a little space-time here. So from 6 p.m. till 8 p.m., a couple of hours really looks like a meetup. So maybe there was a meetup which is both locals and tourists. Not likely, but might be. And here in the downtown, lots of them. So this is how we use this idea of using space and time simultaneously to visualize this data and understand what's going on in the cities and try to show that maybe it's not such a big problem. Or I'm not here to make the conclusions, but the idea is that you can see the conclusions yourself usually pretty easily. The alternative would be to look at 24 maps, each like 24 times, or slide through them and forget what was going on the previous slide. And we think this makes sense. Well, if some people think that doesn't make sense and ask, how did you come up with this cube? Why did you decide to make a cube? Well, we thought that it makes sense for two reasons. One, people are familiar with maps, and people are familiar with timelines, so we don't introduce some, so we're based on some solid grounds. And two, is that we use to manipulate this new entity, we also use some known approach, which is, for example, here we were influenced by fMRI. So in fMRI, it's a process of scanning human body and checking its density of the tissues inside. And it's done using arrays, and you get as a result a 3D visualization which consists of voxels which show how dense is your area at different locations in your head, for example. And there are lots of techniques and software which lets people who are interested in looking at fMRI explore it. So you can make different cuts, you can select different areas, and you can select different time intervals. And that's what we did in this Chronotope software we will show a bit later during the walkthrough. So you can cut it, you can select a subset of a time interval, and you can dive into the cube as much as you want. You can rotate it around. So it's not a constant cube, which is like here, which is hard to see when it's static. You interact with it, and we think it's very important to have a high response time of interaction. So you intuitively start to feel how the city is operating through space and time. Sorry. So here's an example of using a slice. And so here we selected one street in Barcelona and just made a cut through the volume. So now we don't see all the data, but only see the data here on this street. We focused on it, and we see that here it looks like a regular people's life. Like the darker colors, the higher the amount of posts. But what you can also easily see is where is the bot. So where is the location where just spam user was automatically posting updates all the time? And it's obvious it's here. So this location doesn't follow any usual, and it's actually true. In the data we saw there was an account that was just posting 24/7, and if he knew that we were following him through Habidatum, maybe he would adjust his behavior to be more human-like, but well, he didn't. And it's perhaps pretty natural for any individual with little experience to see that there is different areas and that they behave differently in time. And we think that this is very important. One more concept that was important for us is that we, in our space concepts, we focus on a regular grid rather than this administrative or some other custom borders for multiple reasons. First, we can have in this grid, it's pretty universal, and you can adjust the size of the cell. So if you want to look at the whole city, you make the cells 500 by 500 meters. If you want to focus on a small area, you make the cells 10 by 10 meters. And no matter what data you have, you can always make it from the initial format to the grid format. What's also important that this is pretty neutral. It doesn't involve any human decisions on how one should define the borders of anything in the world. And we can use it no matter which country we want to operate in. So this was pretty important for us, but it also has some challenges. For example, we want to make the square grids, but if something is square in the meter space, for example, you want to make it 100 meter by 100 meter, it's not square in the latitude and longitude because Earth is not square, it's a sphere. And there are some challenges we had to face to make this workable and to handle the fact that lots of data is stored as latitude and longitude, and we need to make it rectangular. And if you're interested in which challenges we faced, we can talk after this presentation. And the other challenge was the time zones. Because now, when you work with space and time, different spaces in the world have different time zones. And these time zones also have some challenges. There might be some changing of the daylight saving. You can switch hour, and you want to show, like, how do you do that? Do you show two slices if you move the hour, or you show a gap, or this kind of challenges were there. And also the data that is stored on websites, on open data websites, it sometimes often misses this time zone information, which is important and hard. But yes, the result, we ended up with this 3D cube, which is, so we have this format of storing the data, which stores them in these temporal slices. And we think it's pretty universal and can be applied to any city and any data. And what's also cool about this is how the software looks about the grid, is that since it's uniform, you can reason not only about the fact of when and where something has happened, but also about the effect that it had in space and in time. And we do it by blur. Usually, you make a blur in Photoshop when you had a certain value at a certain pixel, and you want it to have some influence around it. And you can make a blur radius of 1, of 2, or 3, and it makes your value somehow influence your neighbors. We can also do the same in this visualization. It helps for two reasons. First, we can think about, we can show the effect some data point had not in the exact location, but around it in space and in time. So for example, if you if you ate something at a shop, it had a certain influence about a certain radius around it because you walked around, also you bring some money to this place, and also there is certain effect in time because before making this transaction, you came into this place for some time ago, and you might stay there after some time ago. So we can make these blurs to show the effect of time. And also we made, instead of showing just pixels which are not anyhow connected, like we did in Barcelona, we make this nice interpolation, which connects multiple values from different voxels into a single entity, which we believe is often easier to reason about. So you can see a certain location, which is spread across space and time, and you find that this is, okay, this is Union Square, and this is how it behaves. So we don't, so our mind, it can analyze these entities, which are not, there are not that many entities if you try to connect them together, rather than just look at the whole cube and think about it. So that's actually, there's a question, but that's actually it for this part, and we'll move to Washington, D.C. examples, but let's answer the question. Thank you.
Yeah, I think what you were just showing, back to that, so that's all the same underlying data, it's just you're adjusting a parameter, which is for every point, how far the radius is going out to average?
Yes.
Okay.
So, yeah, the question was, is it the same data? Yes, this is the same data layer.
Yeah.
We just, like, what's happening here, like, it's the same data here, we just filter to show the high values,
Yeah.
and then we say, these high values, they have certain influence around
So
them.
that does, when it gets really small, like
That's
there,
what- yeah.
that's the radius is decreasing, yes.
Well, actually, initially, let's follow it. Here it's really small because we're filtering to show only the high values, and these high values, they are in the middle of our voxels. So we're like cutting out voxels from outside. This is kind of weird. So the idea is that each value in our 3D, in our voxel is in the middle of this voxel, in the core. So since we want to interpolate, we say that at this voxel the value is 100, and the nearest voxel value is 5. So we make a continuous interpolation from 5 to 100. So there are certain values between them. And when we start filtering out, we just show the scores. Well, it's hard to talk about it without the visual while it's moving. So let's talk about it.
Yeah.
Thanks for the question. And thanks. Yeah.
Thanks, Nikita. Nikita did better than me, and he's sick, so thank you. So we looked at, I'm William McCusker. I'm based in New York and work on strategy and business development for Habidatum. And we took a look at what data sources were available in Washington, D.C. And it's pretty good open data available here, which was cool. And we actually added the data that we could to our trial environment. So after this meetup, you guys are free to sign up and check it out and play around with the data yourselves. If you have some of your own geospatial data sets with timestamps, you can upload those as well. And the data we were able to add, one was bike share data with starts of trips and end of trips, which I haven't done too much exploration of, but maybe we'll do that after I walk through the other data. Crime data, which is always really cool to look at. In this case, I think I was able to find data for 2017, and in fact, actually, it goes back pretty far, and it's fairly recent, so that's a data set that you could do some real-time work with. And on this image, we're actually looking at the 24-hour distribution here, and which we're surprised about. A lot of cities don't have data this granular on crime. Like London, for example, it's aggregated to the month. So this was interesting to see. Here in blue, I believe, is June. And in yellow is January. So we approximated all the days in the given month and then aggregated them down to their distribution across the day. So you can end up seeing, when crime is beginning earlier and later in the day, which could have to do with heat or daylight savings time or a variety of things. And so if you compare June versus August versus January, you can start to see how, the time of year, seasonal changes, whatever, might affect your crime rates and its distribution throughout the day. In this particular data set, I didn't break it down by subsets, like whether that's harassment, assault, or whatever. But we can do that type of categorization, which is another way to start to blend layers. So where are people getting robbed and assaulted at the same time? I mean, that's not a fun example. But where are noise complaints happening and also people are getting robbed, or where are health inspections failing, and there's also reports of rodents in 301 complaints. So those types of correlations are super important to make. And not from a spatio-temporal perspective, not mind-blowing, but in some cases when you're focused in on a use case, when you add the time component, it's another dimension to draw into the kind of causation for these types of correlations. Did we look at any other on here? Hold on. It's not moving. This is PowerPoint's fault. Hold on. Yeah, okay, cool. This is city service requests, popularly known as 311. Does anyone call 311? It's I've never done it. You do it. Yeah, I thought you might. I'd like to start. I did a lot of exploration of 311 data in New York, and it's pretty cool. It's amazing how many people are calling and complaining about things, or notifying people about potholes, or talking about, I always talk about rats, and every time I speak, the rat complaints in New York make you want to leave. And health inspections, noise complaints, things like that. In this case, this was just the aggregate of complaints, all subsets, all types in DC. But you can see some of the flexibility of the z-axis here, which is something that is pretty cool. So the way we work with time is not necessarily like chronological in the traditional sense. I mean, it is chronological, but we can separate out certain days. So you might want to only look at rainy days, or only look at days where there's a soccer match or a baseball match by the Nationals. All right? All right. In this case, I looked at, I think, Saturdays in 2016. And this kind of warmed my patriotic heart that no one was really complaining on July 3rd. Yeah, they took a day off, which I thought was strange. But this is one of those things where, although these are complex, when you start to zone in on like these particular distributions of time, these patterns can start to appear that otherwise would be very difficult to see. Like Nikita said, you know, if you were looking at 365 days, that would be 365 static maps. Or you can come up with the idea to look at just Saturdays, and with us, that type of thinking we built into the software, so that's a matter of clicking a few buttons rather than doing some like heavy lifting that you might be required from another piece of software. Not to be too pitchy, but you know, that's kind of the logic behind the way we built the system. I think Nikita, yeah, we have some social media data on the trial environment as well. I think that's hourly. We work with social media all the time. Other data sources we work with, just to reiterate some of the stuff Nikita said, that we don't have in the environment, but maybe one day we will. We work with mobile phone companies pretty often. That's generally not open data, so not available, but quite insightful and interesting. And privacy concerns there are also pretty interesting. In fact, one thing that we were talking about in the Q&A the other day at Cooper Union was, you know, what are these proprietary data sources doing to safeguard people? Because when the data analysis gets more sophisticated, I think people get more freaked out. And from a telecom perspective, what they do is they aggregate people into clusters. So you can't follow where one person is moving around the city. It's 15, and in the UK, for example, and in France, I think it's 20. So it actually varies from telco to telco and country to country as far as regulations go. I actually, fortunately, can't tell you what the rules are behind what AT&T and Verizon do, but I'm sure it's you know, quite rigorous. Let's see. I think that is kind of it on my spiel on DC. I will put up a link for those. I don't think many of you actually have laptops, but for those who do, feel free to sign up and play around. Hopefully there are some more questions, so we'll take a break and answer some questions. And then after that, I'll dive into the site itself, and provided the internet speed is adequate, you guys can be sort of, you can control me, or I'll walk through the site, and but if you want me to do something or talk about something, I will. So yeah, thank you. And I think we have another microphone. So are there any questions from the audience about space or time or what we do, projects we've done, etc.?
So how do you deal with, so especially if you're getting data from mobile data, how do you deal with connectivity issues where, you know, sometimes the provider or the Wi-Fi drops and so you don't have that data? Is the data saved on the phone and then given back over time, and do you recapture that time, or do you just treat it as missing data and just take an average of the voxels that you take a look at?
That's a good question. Maybe these guys can answer it better than I can, but my guess is that it's missing data. And I'll show you guys when I walk through. And you know, one of the values of the way we approach data is we also look for voids in data. So it's not always about where the data is, but it's also about where the data is not. Sure. So yeah, I think figuring out and coming up with when people come back into the situation is something maybe the cellular providers themselves might do. Sure. correct me if I'm wrong, can we do something?
Yeah, what we can do is, if it's not a specific location which misses data, but rather a specific time period, at like at 5 a.m. at one day there was a missing signal, we can make an average day and try to neglect this one peak of absence of activity and look at it at the hourly distribution to still see what's the average value at this place, and maybe just remove outliers. That's what we do when we try to look at this long time periods. That's another approach, but Moon was right.
So you guys do data cleaning of the data?
Yeah, we generally have to. I mean, you know, this is a pretty new piece of software, so we try to make it to where the data can be cleaned and you can just drag and drop as people come to expect. But yeah, we end up doing a little bit of cleaning ourselves, especially with open data. Although DC's data was pretty clean, gotta say. It's impressive as far as open data goes. But you'll throw in another data set, and all of a sudden there's like lawns in Nairobi or something, and it's just you gotta clean it up.
I was wondering, what's the mix like between what gets processed in the browser versus on a server?
Yeah, I can.
That's a great question.
So, what I can show you here. So, it's a really interesting question. And I guess to illustrate, I need to open the website. So we really are processing lots of our data. Where is the Chrome? I'm sorry.
It's there.
Is it there?
Yeah, there you go.
Okay, bring it on. So this is this software. So it's all web-based. So you can just go to a website on your laptop and let's say open average day in GC project. So what's going on here is that now I start to rotate and you see the visualization, how it's changing. The cool thing is that all this image is rendered on the server. So what's rendered on the client is just the UI. These elements all around, this is what we're rendering on the client. And this image, what you see here, is just a stream of JPEGs coming to your browser, which sounds pretty insane. And yeah, so you feel like it's pretty real time, and you can do a bunch of stuff, like clicking inside and doing different activities. But what's going on is all I'm doing here is just dragging my mouse over a JPEG image on the screen. And it's all rendered on a remote server. This is because there are multiple reasons for that. Not only one, the data is huge here. We have a pretty big cube, and we cannot, if we wanted to, we cannot download it on a client because it would take too much time and lots of traffic. Two is taking lots of power to visualize this data, and we use GPUs to visualize it, so it's all GPU based. And three, this allows us to make data that was closed more transparent. For example, cellular phone data, you cannot give consumers access to this data, but you can give them a view, a way to interact with it in a way that they don't get the data set itself, but they see representation in space-time view. And all the data is on our servers, and we only stream images that show how the data is distributed across date and time. So these are three reasons. And yeah, this is just a stream. We can, if you're interested in some technical details, we can really talk to this, some fascinating stuff if you're into that topic.
Anyone else? He seems to know the answers better than me, so. Is that, oh, there we go.
So since you guys capture a lot of temporal data, I mean, the first thing that comes to mind is that you have all this data that you can easily do some predictive analysis. So have you guys started looking at things like machine learning or any other type of predictive analysis that, you know what, we have all this data and now for the next day we predict that we're going to actually have a lot of activity in these regions?
So yeah, we didn't move that far into this area yet while we were thinking about it. What type of machine learning we're trying to apply is that we want to make it possible for a user which not make many decisions about what to see exactly, but just show him a specific and very interesting outline areas in space and time. So he can just click a button and say, show me where it's cool in DC and when. And he just, boom, it's here. And that's what we're trying to build on. And I guess, yeah, so it makes sense to make predictions at specific locations in time, but most of the data is pretty dense, and you need a really long temporal data sets, which are not that many actually. So lots of data is about, it's a few months, usually. If we talk about carrier data, it's weeks, and there's not that many data points in time to make robust predictions, but yeah, we're working on that.
I think not yet, really. I mean, we've been focused more on pattern detection and anomaly detection as our main kind of product offering. We have done machine learning, but not totally in the predictive sense. Like we'll do machine learning to extract the place names from the words into tweets, for example. And I don't know, Vadim, did you want to add anything to that? This is Vadim, he's our CTO.
Yeah. Hi. So I just wanted to make a photo. So basically, we think that we should focus for now, for at least for a year or two, on the topic of visual anomaly detection and helping to improve this intuitive exploration of data by better user experience. Because there is currently a lot of companies who are doing deep learning stuff and classical predictive analytics, but we think that our uniqueness is that we are able to provide this more humanized user experience into data analytics. And this is why we think that we should start with the highlighting, like important concentrations, because algorithmically this is a simple task, but in terms of a user experience, how to do it visually, it's a really hard task. And I think right now all of our work is about designing this user experience, how it should how it should work, and algorithms at 20% support.
And we'll do one other thing that's kind of in that area. We'll do a lot of the trend blur type of functionality to try to highlight these trends in space and time. So to a degree, if you're blurring the trend and trying to predict a little bit into the future, if there is a spatial trend, you could say that, okay, maybe this is going to continue by blurring that data.
So yeah, this is how the blur works. So this is the initial data, and as I said, now we look at it not in the rectangular forms, but in this continuous, nicely shaped entity view. And we can change the blur to make it affect other areas in time. So I can see that now you affect 5 hours, now you affect 6 hours in the future, and this is how we can reason it out.
Hold on. So yeah, just to show you a little bit more of the software, like the bottom is, you can move the base map up. So here, if you're just trying to see, where is the highest concentration of social media activity in October in DC. So you have a different setting. Don't touch the bottom. Okay. There you go. So it's starting to become predictable. You see these outliers here, which are worth exploring a little bit more. But you can again continue to filter more. Hold on. And now you have this area right here. Looks to be like an area worth exploration. And so you can kind of bring the bottom of the base map. Actually, that's kind of near here, isn't it? Yeah. No, there's Reagan. So yeah, and so you have this area between like 1 p.m. and if you bring the base map down, so this is 1 to 2 p.m. in October. That you're having this high concentration of social media activity. Actually, I got off topic now. I'm just demoing. That's that question. One second.
Yeah, on the machine learning tip, so I hear you saying you're not trying to go predict it, but are you doing any like cluster analysis kind of things for pattern detection?
Yes, so we have this clustering functionality right now built into software, but it's not public yet because we are like fixing it. I mean, in terms of user experience, and this highlight feature that Nikita announced previously, it will also be based on our like previous clustering attempts. So I mean, how it will look in the live software is that we have this like thing which allows us to highlight an arbitrary spatial temporal cell, and we are like looking into clusters in 3 dimensions and then highlighting with this tool. So what we are trying to improve right now is the user experience which allows people to see the reason why object is highlighted, I mean somehow visually, and also to see the list of highlighted objects, so you will be able to switch. The camera will automatically move to most interesting points, so it's a lot of like a micro working, and this is why this feature is not still there.
Thanks.
Any more questions?
I'll just speak. So how do you approach it when the users don't have their geolocation turned on?
That's a good question.
Well, the Twitter example is like, let's say 10% of tweets are geotagged, but if someone tweets that they went to ByteCubed, we can figure out that ByteCubed is here. Or if they say Joe's Candy Shack or whatever, we can figure out that it's at wherever Joe's Candy Shack is. That might get more complicated with places like Starbucks or something, but you can start to a certain degree, like extract some coordinates from things just based on word choices. But yeah, sure. I mean, if there's no data there, it becomes difficult. So we are limited, definitely, in the type of data that we work with. But I think there's an increasing set of data that's geotagged. And those that turn off their location tracking are doing themselves a good service to some degree. But if we're making our urban planning decisions based off of those that are, then it actually, I mean, that's an interesting point. Good question.
Have you looked into, like, firstly, for example, like the Twitter users, like there's like all kinds of possible reweighting of the user demographics, and then secondly, adding this option to allow users to choose different like reweighting methods in the API.
Did you hear that, Nikita?
Sorry, can you repeat it closer? We missed it.
Yeah, just hold my like this. It's hard.
I heard demographics.
Yes.
Reweighting.
Yes, reweighting user demographics, and like obviously there are like user demographics is the only like situation where like reweighting would be like appropriate, and like firstly have you like consider like doing that, and secondly adding that option to the API for users to choose between different reweighting.
Okay, so as I understood, so how we can filter the demographics and the data, right? But basically, what I'm doing with the Twitter data is that we're using the raw data, and then we apply some kind of algorithm. For example, with Barcelona data set, we applied an algorithm which looked at history of people's tweets. And if I, for example, tweeted a lot from a DC, I will be local. And if I tweeted several times from a DC, I will be tourist, because algorithm will check locations where I was before. And so if I was, most of my tweets are, for example, from Moscow, so I'm a Moscow tourist. And in our software, we have this categories here, which allow us to filter via arbitrary labels. And basically what we are doing, we are labeling the data inside of a data table, and then we are able to filter through these categories in a matter of like microseconds, actually. because we, during the import phase, we index all data, we index categories that was marked by users. And then we are able to filter by these categories. I think we can show how we can, for example, filter through approximated points of interest. So yeah, we can enable this.
That's my game.
It's time to what?
Yes, and internet is not nice on us with all the streaming everywhere.
Yes, so because we stream our software, we stream to Chromecast all the way around.
So you have this in New York, the layer of the open hours of different types of businesses, and you can choose between which types of businesses you want to focus on. And we see that professional services are open at these times, car services are at different times, art and culture at different times and places. And also about the question of waiting, this is something that's all about the preparation of the data set before importing into the software. So software itself does not wait based on demographics, but you can do it, and we in our projects also can do it to prepare the data in a way that we're weighted by how many people use in this age and how much people are there actually. So this is the question of preparing the data before importing it. This is just a domain expertise which we cannot incorporate expertise for each type of data set.
I also think, if I understood the question correctly, like in the case of Twitter, maybe however many percentage use that service in a different population. It's one reason we work with mobile phone data a lot. It's arguably, ubiquitous at this point, the mobile phone usage. So if you have that as your kind of population proxy, then you can just utilize the Twitter data to supplement that more robust data set and draw correlations between the two. Anyone else?
I was wondering if you could just share one or two examples, some of your clients you've worked with, what problems you were trying to solve for them, and what some of the results were, whether it's efficiency gains, economic insights, things like that.
Yeah, it's pretty diverse right now. We've just now, even in the past month or two, been transitioning from mostly consulting projects, which were with big, Deloitte type people, to now a product company. And we've worked with architecture bureaus a lot. We've done work with Zaha Hadid that's on our website now on a pedestrianization kind of walkability study in London. So working on determining what are the areas in London that are prime for turning into pedestrian-only streets or zones. And that was, again, kind of bringing our expertise on getting a hold of these proprietary data sources, crossing them with client data, and then visualizing them and creating these unique statistics to follow to kind of prove or disprove the theories that Zaha Hadid Architecture is lobbying to the mayor's office. That's one really clear and recent example, or sort of clear maybe. We've also worked on airports, well, really just one at the moment. I'm not sure how public it is, but it's a terminal expansion project. And the idea is that airports are right now, for the most part, just if you look in the outskirts of the terminals, it's just this logistics wasteland. So it's cargo, it's it's mostly cargo, and then just nothingness. And they're usually, in the case of Reagan, for example, it's good real estate right here. And so the idea is that those, and then there's been books and papers and stuff written about this whole concept of aerotropolis and stuff, where these areas can be mixed use. They don't necessarily have to be these logistics wastelands. They can be an additional shopping zone, or it can be mixed use for commercial and residential. And where we come in is we can help determine, is it on the northwest corner that should be commercial, or the southwest corner? Should the transit hub be in this voxel and open from on a 24-hour scale, or should it be in this voxel and open on a 12-hour scale? And are these people that are coming here mostly passengers, or are there people that are actually living in the nearby area that are commuters? Or is the surrounding area of Reagan actually dominated by people who work at Reagan? That's, again, you know, oftentimes we work as a subcontractor in that case, like another architecture bureau we work for. Otherwise, you know, commercial real estate is an area that we're interested in working on. I mean, at the heart of our company, we're urban analysts and urban planners, with the, you know, kind of a deep appreciation for design. And so I think we'll definitely stick around with the architects because they've been our, you know, early evangelists. So, you know, we need someone who is both into data and also into design to get behind us. But the smart city space is another area that I think has been starting to come around. You know, it's been a concept and a word and something that people have been using for a long time now, but up until, I think, you know, very recently, it's been more academic and more of a conference and exhibition activity. And we've done, believe me, I mean, before I joined the company and till today, a lot of our work has been exhibitions, going to IoT conferences, going to Smart City Barcelona, this type of stuff. But now all cities are starting to get on board. I think they're all just really excited about the idea of self-driving cars. But the smart city market is an area that we are actively pursuing and have a few different cities that we're talking to at the moment.
These are really interesting visualizations. Would it be possible, though, to have them up online, say, for example, like something like a D3 visualization, that say if you were posting some sort of, say, data analysis, that a user could actually go and hover over them and see different data points?
Yeah, I hope so, one day.
Well, you can go online right now and see this visualization.
Yeah, I mean, right now, like, I think what he's saying is like if you hover over yellow, it could say theater and stuff like that. Yeah, I mean, that's like a cool feature, and I think like to a degree we could probably implement something like that if I make these guys or it gets ahead of all our other laundry list of features to implement. But otherwise we can go over and show them that, yeah.
Right now you have this highlight, not highlight, you can have this marker, you can make spatial, you zoom in, you feel how the internet is not that fast.
Just hit one we've already made.
I just want to create a new one. Oh my, that's too close. What is a hovering? Oh, stop. I don't know. So now, yeah, you put a marker here, and you can see first the address, you can copy it, the license longitude, and all the statistics for different players. You can then try to move it around, do that.
Yeah, it's you know, subject to internet speed, but each layer is then listed when you create a marker to explore. So, I mean, it's not your typical 2D interactivity that you kind of grow to expect when you're hovering over an election map or something. I think that's partly because we've been focusing on the analytical use cases as opposed to the kind of iframe New York Times visualization. But yeah, I mean, one day I'm sure we'll do that.
It's also pretty hard to make a hover because since it's all done on the server, you have to send a request to the server and back, and it's hard to make it hover-like feeling in this sense.
Maybe only in 2D or something.
Yeah.
Any other questions there in the back?
Thank you. So you mentioned intuitiveness a couple of times during the talk, talking about visualizations. But when we look at these pictures, like there's a lot of cluttering. It's hard to read through and exactly understand what each voxel presents and where it maps to. And overall, 3D visualizations are harder to read than the 2D ones. So another approach could be just using 2D maps with a very intuitive, interactive way to look through the time. So I understand you've been working on this for a while and working with different clients. So are there any specific reasons that you went with the 3D visualizations? Are there any strengths? And I mean, the weaknesses, I think everybody can see more or less about how to read this data. But yeah, any specific reasons why you went with the 3D visualizations over here?
Yeah, absolutely. For me, I think there's a lot of underlying philosophy behind the decisions, but for me, I think the idea of specifically the anomaly detection aspect, like if I'm going to give this to a client, I'm probably going to give them like a 2D version as in end rendering, maybe with a 3D version beside it, to show how I got to that result. Because yeah, if you're looking at a static image, the 2D is really easy to read, and I can say, okay, this zone at this specific time is my area of opportunity or my area of risk. This is where there's fraud or something like that. But to actually discover that area where there's fraud, for example, to look at it in 3 dimensions when you're looking over, let's say, like a few years of data, very granular data where the fraud activity happened in a singular hourly instance, to detect that requires, at least for us, our hypothesis behind this is that utilizing this in 3D and having this interactive experience of being able to filter layers in time is the best way to find these patterns and trends. Otherwise, like, we do have the animation capabilities and things like that in 2D. Yeah, exactly. So yeah, but we definitely have clients who ask that exact same question, and my answer is the one I just gave usually. So hopefully that's sufficient. But I mean, happy to continue that conversation. Anyone else? What time is it? How are we doing on time?
Pretty good.
Yeah.
It's 8:12, so yeah, we can wrap it up.
Okay, cool.
No more questions? All right, so I guess, anything more? You want to say anything?
I want to say thanks.
Oh yeah, okay, so, well, thank you to our speakers. Let's give them a round of applause. And thank you for asking like really good questions. They were able to actually demo a lot of their features based on just the questions, so it was really great. So we'll wrap it up quick. We'll wrap early today, and then let's just go to Highline if you want to talk to them or more questions. So thanks.
Yeah.
Thank you.